Everyone. Welcome to part 3 of chapter 3, Shape Setter and Spread. So this slide right here with directions from the textbook, you're given the page numbers. I meant to put that at the end of the last video, but these are the page numbers where you can get directions for creating a box plot and the 5-number summary. All right, so um, I want to teach you a method, a common method for determining whether or not something is an outlier rather than just saying, hey, it kind of looks like it is. All right, so here's a set of data. And just at first glance, you know, looking for outliers, 6 isn't that far from 9. It's not that far from 11. But over here, when you look at 26, you got a pretty good leap between 17 and 26. So it seems like 26 might be an outlier. So I'm going to show you guys how to use the 1.5 IQR method to determine whether or not there are outliers. So the way that you do this, you first need to focus on where quartile 1 and quartile 3 are. So quartile 1 is at 11. So at 11, I'm going to mark quartile 1. And quartile 3 is going to be at the 17. So Q3. Remember, this is also referred to as lower quartile and upper quartile. All right. So the 1.5 IQR method is if you go from quartile 1, if you go to the left 1.5 times IQR and you make a mark, anything below that, we call it creating a fence. Anything less than that number is going to be an outlier. And over here at quartile 3, you're going to go to the right of that. You're going to go to the right of that 1.5 times the interquartile range. So both of these measurements depend upon the interquartile range. So that's the first thing we're going to do. We're going to calculate interquartile range. Well, remember, interquartile range is just Q3 minus Q1. So we're going to do 17 minus 11. So our interquartile range is 6. So now what I have to do is I have to do 1.5 times the interquartile range. And I need to go to the left of that. I have to go less than quartile 1. So if I'm going to be going a certain number of units less than 11, I'm going to have to subtract. So what I'm going to do is I'm going to do quartile 1 minus, and I want to go to the left of that 1.5 times interquartile range. Well, remember, quartile 1 is 11, and 1.5 times IQR. Oh, I haven't calculated that yet. All I have is IQR. So now I have to do 1.5 times IQR. That's 1.5 times 6, which is 9. So I have to come over here. Quartile 1 is 11. 1.5 times interquartile range. 1.5 times IQR gave me 9. And so that equals 2. So I'm going to put a fence over here at approximately where 2 is. I don't have any numbers less than 2. So there's no outliers here. A 3 would not be an outlier. A 4 would not be. A 1 would be an outlier. All right, so then I went from quartile 1 and I went 1.5 IQR left. Now I have to go to quartile 3 and go 1.5 IQR to the right, which means I'm increasing. So quartile 3, increasing is adding 1.5 times IQR. Well, this time we've got the IQR times 1.5 right here. So quartile 3, 17, plus, we've already done the 1.5 IQR, that's 9. So that's 26. So our lower fence was at 2, our upper fence was right at 26. There's nothing to the right of 26. 27 would be an outlier, 28 would be an outlier, but 26 is on the fence. It's not to the right of fence. So in this one, we have no outliers. Right? So the key to finding outliers using the 1.5 IQR method is right here. Q1 minus 1.5 IQR, Q3 plus 1.5 IQR. All right, so let's take a look at standard deviation. So I'm just going to be doing population standard deviation. So we're going to be dividing by n instead of n minus 1. So this is our symbol for population standard deviation. If it was just an S, that would be sample standard deviation. So in this scenario, we're assuming that these four numbers are our entire population. We have 4 of something. Okay. So as always, when you start doing some calculations, you do what's in the parentheses first. So I'm going to do this first. So that's a symbol for mean. And I'm going to show you in Desmos how I did that. TI-84 will work as well. Okay. So in Desmos, I went over here to functions. Right? I hit stats and I selected mean and I typed the numbers in that I wanted. And it gives me 84. All right. So my mean is 84. So X is all my individual numbers. So all my data points, 80, 84, 85, 87. So I listed all my X's. And so now I have to do all my X's minus the mean. So I have to do 80 minus 84. 84 minus 84. And so on. And so now, after you do that, you have to square it. So that's a negative 4. If I square it, makes 16. 84, 84, 0 squared, 0. 85 minus 84 is 1. You're going to square it. That becomes 1. And then 87 minus 84, square it, you get 9. All right. So we've done X minus the mean. We've squared it. This symbol right here, capital sigma, that means the sum of. So now I have to add these up. 16 plus 1 plus 9. That is going to give me 26. Right? Now, once I've done that, I've done X minus the mean squared. I've summed it up, divided by N. Well, N is your population size. That's 4. All right, so the next step is 26 divided by 4. All right, 26 divided by 4, that is going to be 6.5. 6.5. And then once you've done everything inside, the last step is to take the square root of 6.5. Okay, let's come over here. We're going to put in, where's my square root button? And 6.5. We get let's round that to 2.55. Come back here. 2.55. That is our standard deviation. Okay. And using Desmos, I think I've already put that in. I'm going to scroll down just a little bit. All right, so you can see there, I went over here to functions. I hit stats. I picked standard deviation P for population. I typed in my data values, and look, we got 2.55. So I'm just trying to let you guys see how you can do this on Desmos if you don't have a TI-84 calculator. All right, so that is how you calculate standard deviation. There are going to be some shortcuts on the TI-84. I've also just showed you how you can use it on Desmos. Now, I want you guys to notice here, got these 4 data values, and our standard deviation was just 2.55. Okay. Now, I have the same 4 data points, except I added 100 to it. And I want you to see what that does to the standard deviation. Remember, with just the 4, standard deviation is 2.55. Remember, standard deviation is a measure of spread. Standard deviation of 2.55 means on average, each data point is 2.55 from the mean. That was true if we didn't have the 100. All right. Now, if I include the 100, it's obviously much more spread out, right? We've got what's probably an outlier there. Now I'm going to go back to Desmos and let you see here. What we have here, once I tack on the 100 and I ask it for the population standard deviation, it jumps to 6.79. All right. So one outlier has a huge effect upon standard deviation. So when you have outliers, they're going to have a tremendous effect upon standard deviation. So standard deviation is not a good number to use when you have either skewed or outliers. So, but the only time you want to use standard deviation is when you have roughly symmetric data. So when you have roughly symmetric data, you want to use standard deviation for spread and the mean for center. And then if you don't have symmetric data, and we talked just a little bit about this before as far as the mean goes, if you have outliers or if you have skewed data, that's when you want to use median and IQR. Okay, so if you have non-symmetric, you then want to use IQR for spread, and for the center of the data, you want to use median. Right? And the last thing I want to show in this video is some TI-84 tips on page 69, how you can do mean, standard deviation. And the symbol the calculator uses for mean is the X bar. Technically, that's sample mean, but your calculator doesn't know whether you're asking for a sample or not. You determine that based upon your information. And here's the symbol it uses for standard deviation. It won't use, sorry, it actually will use S of X. So I need to fix that for you. Erase. Forgot about that. I don't know why I put that like that. Your calculator will actually use S sub X. So it uses x bar and s of x for standard deviation and mean.